right, guys. We have Maxwell and Vipin from Amazon talking about Amazon EKS-Anywhere on Apache CloudStack. Take the stage, guys.
All right. Hey, everyone. Good morning, good afternoon, good evening, depending on where you're joining from. Super excited to be here for this session with you all. So we're going to be talking about Amazon EKS-Anywhere on Apache CloudStack. My name is Vipin Mohan. I'm a Principal Product Manager at Amazon Web Services. And I'm joined today by the amazing Max. You want to introduce yourself?
Sure. Yeah. Hi, everybody. My name is Max. I'm based out of North Carolina, United States. I've been at Amazon for almost 5.5 years now, and I'm working in collaboration with Vipin here on the EKS-Anywhere project.
Cool. Awesome. Yeah, like I mentioned, this, like Max mentioned as well, this project has been a collaboration across multiple people, multiple communities, and multiple organizations. Max, if you can go on to the next slide. So we want to start off by giving a huge shout out. Besides Max and myself, there were many people who helped bring this project to life. It was a collaborative effort across different people in the CloudStack community, and what's been over a year's worth of effort. We're super excited to talk to you about something that's right now generally available and ready for production. Next slide, Max. So in terms of our agenda, what we'll start about is talking about customer pain points when running Kubernetes on premises. Kubernetes is becoming a de facto compute layer or substrate for many of our customers. And for some different reasons, they want to run Kubernetes on premises. And we'll talk about what are the customer pain points. We'll also spend some time talking about what is EKS-Anywhere and what does it mean for running EKS-Anywhere on Apache CloudStack. We have some demos along the way so that we can demonstrate what we've built. And if you're interested, we can get you instructions on getting hands-on. We'll talk about the components and leave you with some resources and community contacts that you can leverage. Max, next slide. Great. So like I mentioned, Kubernetes is becoming the de facto compute layer for many of our customers all over the globe. And customers have told us that they have existing investments in on-premise hardware that they want to leverage. They already have data centers. They've invested in server hardware over there, and they want to leverage that. Some other customers told us that they have a regulatory or governance requirements that define where they can actually deploy their workloads. So not every geography in the world has a cloud data center yet. So there are these customers who want to run Kubernetes workloads for governance and regulatory reasons. There's also customers who told us that they want to reduce costs by running Kubernetes on premises. They want to leverage the entire open source software stack for all aspects of their compute. And lastly, that there are other customers who told us that they want to run compute and Kubernetes on infrastructure that is closer to their end users. So think of latency sensitive or gaming applications wherein proximity to the end user is super critical for a great performance and great customer experience. So that's another reason why customers wanted to run Kubernetes on premises. Next slide. So with that as the background, we built Amazon EKS-Anywhere. So Amazon EKS-Anywhere has been generally available from September 2021. So it's been over a year since the product has been ready. So EKS-Anywhere gives you on-premises Kubernetes operational tooling that is consistent with running EKS in the cloud for Amazon. So it builds on the strengths of Amazon EKS distro. We'll talk about that. And Amazon EKS distro is kind of provides a consistency between running Kubernetes in the cloud and on premises. And I do want to call out that all of EKS-Anywhere is open source, and we also maintain the distribution for Kubernetes and keeping it up to date and patched, so that you can have a reliable and secure Kubernetes environment on premises. So EKS-Anywhere also helps simplify the creation and operation of Kubernetes clusters on premises. And what we do is to provide you with some kind of default component configurations as well as tooling for cluster management. And it's all built on open source, and we will continue maintaining all of these the ecosystem of projects that we support with EKS-Anywhere. EKS-Anywhere is built on Cluster API, which is a Kubernetes sub project, and we'll talk about Cluster API and what we've done with CloudStack. So I mentioned, Cluster API is a Kubernetes subproject, and what it does is that it does not lock you into any kind of proprietary technology. It gives you the ability to manage your clusters in the sense like, you can do create operations, update operations, delete operations using the Cluster API standard, while like allowing you to run Kubernetes on premises with some kind of like supported environments. We also bundle key components for networking. For example, there's a CNI plugin that we bundle. We give you an out-of-the-box operating system in BottleRocket. We supply a Flux controller for GitOps purposes. All of these, like our goal is to help you accelerate the readiness of your production clusters on premises. And we'll talk about the third-party components. So we supply a bunch of open source components, and we take care of the supporting and patching on the backend, so that you have AWS as one-stop shop for any support issues that you run into with your clusters. Max, next slide. So let's unpack this a little bit. So EKS in the cloud is fairly common. It's been available for a few years now, and many of our customers run Amazon EKS in the cloud. And EKS comes with a managed control plane, and our goal is to make Kubernetes operations in the cloud simple and boring for our customers, so that they can instead focus on their business innovation. Now, with EKS-Anywhere, we are providing opinionated cluster creation and lifecycle management tooling. What that means is that it's not proprietary, and we are using all upstream Kubernetes components. So we're not forking the project. It's all upstream conformant. But all of the work that we do for running EKS in the cloud, think of like the CVE patches that we put in or security fixes that we put in. All of that is now available as open source with EKS-Anywhere. And all the work that we do is also being upstreamed into the respective projects. For example, it could be the Kubernetes project, it could be the Cluster API provider for CloudStack, and all of this is like upstreamed, and we maintain some of these projects. So our goal with EKS-Anywhere is that customers should be able to create high availability clusters. In terms of operating system, we give customers the ability to create Red Hat Enterprise Linux base image. So customers told us that they have existing RHEL operating system on their premises, and they want to run Kubernetes on top of that. So we give customers tooling and documentation to make their RHEL image ready for running EKS-Anywhere. For pod network policy and CNI, we support Cilium. And one of the reasons we support Cilium is to be consistent with CNI support that's available in the cloud. We also give customers the ability to support API server and OIDC authentication. We're looking to integrate with different identity providers that customers may be using. Could be like Okta or Ping Identity or anything that customers use. We are working with our partner ecosystem to enable those for our customers. I mentioned, we use GitOps. We recommend GitOps as the preferred way for managing your clusters. It's declarative. It allows you to easily manage your clusters. So with EKS-Anywhere, we include GitOps tooling, a Flux controller to help you create, operate, and manage your clusters. And you can do that by pushing a YAML file to a Git repo, and then Kubernetes kind of manages or syncs the state between the cluster and the Git repository. Lastly, I want to call out EKS connector. It's optional. It's also another open source project, but think of it as an agent that you can install in any upstream Kubernetes cluster, including EKS-Anywhere, and you get a single pane of glass view for managing all of your clusters. So you can visualize all of your clusters in one single pane of glass view on the console. So that's some of the components that we have with EKS-Anywhere. And one thing I want to call out is that EKS-Anywhere was launched in September 2021, and we had support for VMware vSphere and bare metal. And today we are super excited to be presenting this in front of you, that we now have support for running EKS-Anywhere on Apache CloudStack. Some of our customers said that they want to run Kubernetes on CloudStack, and we work with the CloudStack community. And today we're excited to announce the general availability of EKS-Anywhere on Apache CloudStack. Next slide, Max. So I mentioned a few times about consistency between running Kubernetes on premises and in the cloud. So how does that happen? So EKS-Anywhere uses EKS distro, which is the same Kubernetes distribution that powers EKS on the cloud. And with EKS, we are helping customers run thousands of applications at scale. And what we are ensuring with EKS-Anywhere is that our customers get to run the same distribution, the same level of like operational stability, reliability, and security across all of their environments, be it on the cloud or be it on premises. And the key difference between EKS on the cloud and EKS on premises, EKS-Anywhere on premises, is that the customer or you own the control plane components as well as the worker nodes. So we provide tooling, but the operations of the control plane is managed by the customer, because we want to support customers who are running in like air-gapped environments, for example, who do not have any connectivity back to the cloud. So that's the reason, like with EKS-Anywhere, you get full control of the control plane as well as the management of the control plane. And with EKS-Anywhere, you get out-of-the-box tooling that we want to make it easier for customers to run and operate their Kubernetes clusters on their own. Next slide. So I've talked about third-party packages that we bundle with EKS-Anywhere. So I'll spend a little bit of time talking about what those components are. To begin with, we call these as curated packages. And the reason we built this was because many of our customers told us that it can become overwhelming for them to find the right tools for each component in the cluster. Think of having to find the right networking plugin, or finding the right container registry on premises, or a load balancer. So what we did was to take the responsibility to find secure and stable third-party components that our customers can leverage out of the box with EKS-Anywhere. So these are bundled components, and we call them as curated packages. So we bundle secure, stable versions of these tools and provide them out of the box. You can also reach out to AWS for support. And some of the tooling that we bundle right now are, with Harbor, which is an open source cloud native project for container registry. Metal LB, which is a virtual IP provider for services of type load balancer, supporting ARP and BGP. We also support emissary ingress out of the box. It's an open source ingress supporting API gateway and layer 7 load balancing. You get, for observability, you get AWS distro for open telemetry, which is again open source, and gives you a vendor agnostic solution to receive, process, and export your telemetry data. You also get cluster autoscaler, which is the component that allows you to adjust the size of your Kubernetes cluster, so that you have the right size instances or right sized servers for running your pods. You get metric server, which is a scalable and efficient source of container resource metrics for Kubernetes autoscaling. And lastly, you get cert manager, which is certificate manager for Kubernetes clusters. So these are some of the curated packages that we support, and we're looking for your feedback. There's additional operational tooling that you would like, let us know. We'll give you pointers to the resource, to the community, to reach out to us, to the community. Extremely happy to work with you on that. Max, next slide. So this one, I'll quickly go through this. So I've talked about EKS distro. That is what gives you the version consistency for Kubernetes across EKS in the cloud and on premises. So we open source the Kubernetes version that Amazon uses for EKS. So it's basically the same major, minor, and patch version that you get with EKS on the cloud as well as EKS-Anywhere on premises. And the result of this is that all the work that we do to test, certify, and build open source Kubernetes versions when they are released are all available to you through EKS-Anywhere. So this is another open source project that we worked on with the community. So excited to work with you on this as well. So that's about setting the context on what EKS-Anywhere is. And Max, next slide. So we'll do a little bit of deep dive on what is the architecture, and then hand it off to Max to take it from here.
Thanks, Vipin. So if we want to just double click a little bit on how EKS works, working backwards from the use case, we have customers that want to run workloads on premise on some Kubernetes clusters. So those may be some process some data, or maybe you're running some microservices. And so before you're able to do that, you need to have a cluster in place. And for this use case in particular, you want to have that cluster on your existing infrastructure, which is managed by Apache CloudStack. So how EKS-Anywhere allows you to do is it's actually a command line interface tool. Since it's entirely on-premise, there's no connection with the cloud directly. So Traditionally, you'll have a administrative user running on some administrative machine, this EKS-Anywhere CLI. And the way it works is entirely Kubernetes based. So it uses Kubernetes essentially with the cluster API framework that Vipin mentioned previously to actually create and manage your CloudStack resources. So in order to install these resources, first you need to have it locally. And the way that EKS-Anywhere does that is through a kind cluster. And what that stands for is Kubernetes in Docker. So it's just a Docker container that's running on your administrative machine, which the CLI is able to install the necessary components on. So those components are defined by the user. So the user will specify what type of cluster they want, on what provider, how big. They can configure the different virtual machines specifications, whether you want a disk offering or any symlinks or any SSH users to be created when the cluster is coming up. And then those resources are installed, the templates are applied, and you have resources that become reserved in Apache CloudStack. So virtual machines will come up for the control planes and the worker nodes, and all come together to join as a Kubernetes cluster. And once the cluster is ready and running in your CloudStack resources, then you can actually go ahead and move the management components over to that cluster. And the cluster becomes self-managing. So you can use those features to scale up and down your cluster, and also provide updates. So one of the other advantages of having this CAPI management is now you have this cluster running in CloudStack, and you can actually use it to create and manage other workload clusters. So it's kind of this one-to-many relationship where you have a single cluster which controls and scales many other Kubernetes clusters, which you can then use to run workloads on. So this is one of the operations that EKS-Anywhere supports, cluster creation. Additionally, you may want to use it to upgrade your cluster. And that allows you to also create this bootstrap cluster so that all the CAPI components can be moved off of your cluster before you upgrade it in case something does go wrong. Those resources are preserved. And then there's a similar workflow for cluster deletion. So the way that this process works is we're using this generic framework called Cluster API. And what that defines is a sort of interface with all kinds of different providers to basically specify what kind of cluster you want and what kind of machines you want running in that cluster. And so you'll see that it's generic across providers with plugins. There's a plugin for AWS, so that's CAP-A. For vSphere, that's CAP-V. You'll also find similar ones for Azure, and now we can proudly say that CAPC plugs in with, that's CloudStack, plugs in with CAPI. And so, as I mentioned, each provider implements these CAPI interfaces for their cluster and machine resources respectively to create and manage the infrastructure for running Kubernetes. And there's a lot more information going to be presented in David Jumani's talk tomorrow about our journey in creating and writing CAPC, which is, again, a cluster API provider for CloudStack. So without further ado, let's dive into a demo by my colleague, Joe Weidekamp. So he'll walk you through the documentation and the whole cluster creation workflow.
Start us off, if I may, with the EKSA documentation set. There is a great documentation set. EKSA seeks to really be a well-supported product, and at anywhere.eks.amazonaws.com, we're going to find everything needed to walk us through getting the basic EKSA cluster provisioned, as well as more of the advanced concepts, as well as all of the reference information about the different data objects that we'll be manipulating as we proceed. So great resource for you to know about. Let me start you off there. And what we're going to do today is create production cluster. So we'll quickly pop to that. And there are several options. We can create bare metal, vSphere, or, as we're interested in, a CloudStack production cluster. Now, as with most things, there will be a bunch of prerequisites, things like making sure you have the right CloudStack template and machine offerings in place, various settings. I've taken care of these already, and I'm not going to do that less interesting part during today's demo. But what we're really going to do, first off, is create a cluster manifest that describes our cluster, and then tell EKS-Anywhere to actually make it so. EKS-Anywhere, as with most Kubernetes products, adapts a declarative mindset. We define what we want to be true in a manifest, and then we submit it and allow EKS-Anywhere to manipulate the outside world, CloudStack, to make it so. So we'll be using the EKS-Cuddle command line utility. This is the standard issued utility for manipulating all things EKS, and it has been extended with EKS-Anywhere with this Anywhere subset of commands. So EKS-Cuddle Anywhere. And the first thing we'll do is ask it to generate an empty cloud config, a cluster config for us. The cluster config shows us all the properties we're going to need to define to create our cluster, specifically for cluster types of CloudStack, and we'll place it in a file. So let's grab that quickly. I'm going to paste that into my command line, and now we've got ourselves a cluster config file. Let's get eyes on it, and we'll do a quick tour and see what that cluster config is. So EKS management cluster YAML is the one we generated. Like all YAML files, this has multiple objects declared with all the nested attributes of those objects, and there are several of them. I want to start, if I may, at the bottom level. At the bottom level, we see CloudStack machine configs, which are objects that simply embody the configuration of CloudStack virtual machines for a certain role in our cluster. And there are three key roles we're going to work with. There is the control plane, there are the workers, and then there's the etcd database. So we have three separate CloudStack config groups declared for each of these roles. Now, in each of them, we're going to have the opportunity to define which CloudStack compute offering to use and which CloudStack registered template to use. We also get to define a Linux user that will be provisioned on that VM, and if desired, an SSH authorized key that Linux user can use to log into the VM, typically valuable during development phases, diagnostics, and such. And if you desire not to for production, that's certainly an option here to omit that. Now, going up a level, we've got the CloudStack data center config. This describes your CloudStack as a whole. And the most interesting parts about it are this notion of availability zones. Now, that's an AWS terminology, but it's going to map directly to the CloudStack zones. So what we'll be able to do here is declare a number of CloudStack zones and their affiliated networks, because each zone has a distinct network, that your control plane and worker virtual machines will be distributed across. The cluster API, which underlies EKS-Anywhere, has the logic within it to know multiple availability zones and to be able to distribute the work across those. Now, we don't just limit ourselves to distributing them across CloudStack zones and networks. We also let you to refine that somewhat by declaring a CloudStack domain and account to use within each of these. And you can even go so far as to declare a different CloudStack management endpoint. So if each of your physical locations, your availability zones, has a different CloudStack management endpoint running, you can distribute your cluster across multiple CloudStacks. Now, we'll need to log into the CloudStacks, of course. We have to authenticate to those CloudStacks before we actually use them. So this credentials ref is actually a reference to a component that's going to be in a Kubernetes secret that will be used. Now, where does that secret come from? Well, let's take a look first at this little INI file snippet, because the secret will be generated from one of these. This one has a section called global, so that is what our credentials reference was pointing us towards. This global pointed us towards this global section in the INI file. There can be multiple sections in the INI file for supporting the multiple different API keys and secret keys needed to authenticate to multiple CloudStacks if you should choose to do so. For our purposes today, we're going to keep it simple and have just this single CloudStack endpoint declared here, and along with them, the API key and secret key that would authenticate EKS-Anywhere to that CloudStack. So we've generated one of these. I could spend some time filling in the blanks for you with the details about the availability zones and the templates, but I don't think that's time well spent. We're a little time limited today. So let's cut quickly to one that's already been created by me beforehand. And what we see here are our CloudStack machine configs. Each one of them refers to a specific compute offering and a template. Now we'll take a peek at our CloudStack backend quickly to see what we're working with here. Forgive the retro 4.14 look. This was an environment that we had set up for some retro testing, but was the best available for today's use. And under service offerings, we see our large instance, the standard large instance that comes with all CloudStack deployments, and that is going to be 2 CPU cores running at 2 megahertz with 2 gig of memory. We also find, let's grab the name of our cluster, let's grab the name quickly of our template. That our template is there. Now, where'd that come from? Two options for you in templates. One is our good friends at ShapeBlue publish a series of pre-generated templates with Rocky Linux and Ubuntu OSs and various versions of Kubernetes, 22, 23, and now for the forthcoming 24. Alternatively, the EKS-Anywhere site outlines in great detail the steps necessary to produce your own. So with EKS-Anywhere, many of the enterprise clients prefer to use Red Hat Enterprise Linux-based templates like we're using for ours. So that process requires using the open source image builder project and a series of steps that are defined over here. So a relatively straightforward 7-step process to create your own template, and then it can be uploaded to CloudStack for your cluster. Okay, so those are our machine configs, and I started with the bottom config for etcd, the Kubernetes database that underlies all the retains all the Kubernetes configuration. We have got with it large instance and our Red Hat Enterprise Linux 8 Kubernetes 1.21.5 template. Now for our workers, same thing almost. We're using large instance and the same template. But what we've done here is incorporate a disk offering. Now, when you incorporate a disk offering into this, that you reference the disk offering that's been predefined in CloudStack. We're going to use small. And it will be provisioned, it will be partitioned, it will be formatted, and it will be mounted into your file system space on all of our worker node machines. The mount point will be /mydisk. It'll be ext4 file system. It'll have a label of data disk. At the Linux level, it'll be device VDB. So you have the option of creating and extending your initial root image from the template easily by simply declaring this disk offering reference within your CloudStack machine config. Now, up a level, we've got the control plane machine config. Here we see almost the exact same thing, except worth pointing out we're using a different compute offering. We found the control planes definitely want more memory than the large offering offers, so we've created a custom one, the EKSA control plane offering within our CloudStack definition. Going up a level, CloudStack Data Center config is where we define our availability zone. This availability zone is using zone 1 in our CloudStack configuration and network shared 1. Account admin under domain root is being used here. The specific CloudStack accounts for creating EKS-Anywhere clusters need to minimally be domain admins. They can be narrowed down. We've published a series of the CloudStack permission rules that are necessary and required to use EKS-Anywhere. So you can tighten up from admin to domain admin, and also you can tighten up further as need be with this least privilege permission set that we also publish. We're again using our credentials from global. I've got a different with my actual credentials in it. And we've got our management endpoint declared here redundantly. Now at the top we see cluster, which kind of pulls all of this together. Some of the interesting things are references, say for the control plane definition, we've got a reference to that machine group that we defined further down below. But we also specify how many instances we want provisioned, 2 of them. We're also going to specify the IP address where we want the control plane to be accessible from. Now, the control plane is going to have 2 instances running it. We need something to arbitrate across those instances. We're going to be using shared networks, as we saw down below. We're using the shared one network. And when using shared networks, one uses the EKS-Anywhere automatically incorporates kubevip, the load balancer, which is deployed onto the control plane machines and creates a virtual IP at this particular address. So while the control plane machines will have their own distinct addresses assigned for them by CloudStack, this virtual IP will be allocated, and kubevip instances running on all the control planes will arbitrate across themselves to elect a leader. One of them will listen at this particular IP and will route traffic off to all the various control planes. Alternatively, you can use CloudStack isolated networks, and when you do so, a CloudStack load balancer will be allocated for you, automatically spreading workloads across the control planes, and also the firewall rule necessary for Kubernetes port 6443 will automatically be dropped in. For those who don't want to use either of those above solutions, the option to disable kubevip, run on a shared network, and incorporate your own load balancing solution is always an option and simply requires some coordination with the deployment process that will follow. Now, we're going to be deploying our etcds in what's called the unstacked configuration, which is a bit different than the typical CAPI deployed control planes, where the etcd nodes reside on the control plane loads with them. For more robust production clusters, we recommend using externalized etcds on their own nodes, because this frees them up from being dependent on the scale of the control plane. They can scale independently. A failure at the control plane level of either the control plane machine or some problem running away with API server will not affect this most critical component etcd and possibly impact its quorum. So by declaring simply that we want an external etcd configuration, EKS-Anywhere will allocate machines for it, configure them with etcd, allow them to elect their leader, and configure the control plane to use them appropriately. We also define a reference down to our worker nodes. We're going to use 5 of them. Oh yes, back in etcd we use 3. Other odds and ends we find in cluster, the Kubernetes version, which we can talk about when we get to speaking about upgrading, a cluster name. And then when I go to the top, some networking parameters, specifically what CNI should we use on our cluster. Cilium is probably the preferred CNI the one I forgot the name of is available. I have to remind myself of that. We also can declare the actual CIDR blocks used for Kubernetes pods and services. So I can now create a cluster with this. So if I come off to my directory here where I've got that file, that YAML file living, I can use EKS-Cuttle with its anywhere mode to create a cluster, providing it the file EKSA demo.yaml. And if I was to press enter, it would chug away for about 10 minutes and actually provision this cluster for me. And when all is said and done, I've got a very well-formed Kubernetes cluster running on CloudStack. We are also pressed for time, so I don't want to spend 10 minutes staring at logs scrolling by. So let me switch gears and show you that I have run the cluster this already beforehand. And what you would see is a log that looks quite like this. Things worth pointing out is that first off, a set of pre-flight checks are run by EKS-Anywhere to validate your configuration in great detail, such that if there are any problems with it that would prevent the cluster from forming, they can be detected early, so we don't waste your time, as well as we don't create resources that fail and need to be cleaned up after the fact. EKS-Anywhere uses the concept of a bootstrap cluster to get things started. This is a kind Kubernetes cluster running on your local workstation. CAPI, the cluster API, is installed within it. And then a manifest is submitted to it, allowing CAPI to create our workload cluster. After the workload cluster is created, networking, CNI is installed, and then the CAPI components that were on that Bootstrap cluster get transferred to this cluster for their permanent life. This keeps all of the details about the CAPI configuration for the cluster with the cluster, such that future operations can easily be performed upon it. After those things, EKS-A installs some custom components, various value-adding extensions that are offered, such as the ones Vipin identified for us before. And when we're done, we've got a cluster. The Bootstrap cluster is deleted, and curated packages are installed. So off on my CloudStack again, if I go up and look at my instances, here are the instances for our cluster. If I sort them quickly, I see that I have my 2 control planes here at the bottom, my 3 etcd nodes there in the middle, and the 5 specified worker nodes up here at the top. Now, when the process completed, a directory was created for me, named after my cluster. And within it, I find 2 important things. I find a reference. I find my original YAML file for future reference, for safekeeping. But more importantly, to access my cluster, I've got this kubeconfig. So let's put that into effect. We'll export kubeconfig. And now I can do a kubectl operation like get nodes to inspect my cluster. And here's my CloudStack cluster with its 2 control plane nodes and its 5 workers. I can get my pods, and as you see, a fairly complicated deployment has been created here. We've got all our CAPI components, we've got the cert manager, we've got the EKS-A value-adding components, things for etcd. I'll get into Flux a little bit later. We've got Cilium for the CNI, core DNS, and all of the other Kubernetes components all installed and ready for us to go on this cluster, and a workload can be scheduled. So I've got a cluster up. Now we want to live with that cluster, and there are several things that come to mind for it. The first off is things go wrong, machines fail. Well, machine health checks are in place. So let's look at that. kubectl in the EKS-A system namespace will examine our machine health checks. Oh, I need a get for that one. And I have 2 machine health checks defined automatically by EKS-Anywhere, one for my control plane and one for my workers. In both cases right now, we have healthy clusters where my 2 expected control plane machines, 2 of them are healthy, and of my 5 expected worker machines, 5 of them are healthy. Right now, they've been up for 80 minutes. If machines should fail, if those VMs should fail, our machine health checker detects this, and if they remain failed for 5 minutes, they get an opportunity to recover, or false positives get a chance to be screened out. If they remain failed for 5 minutes, the machine health checker will delete those nodes and then allow the CAPI components that maintain our cluster to automatically replace them. CAPI, again, is a defined state system, so if I've said if there are supposed to be 5 nodes involved, there will be 5 nodes involved, and if it ever drops below 5 nodes, CAPI will take steps to restore it back to its 5 node level. The other thing that changes, aside from the systems failing, is the software. Software gets upgraded. New Kubernetes versions come out. Cluster API, EKS-Anywhere components all get upgraded. Well, to make that easy to manage, EKS-Anywhere provides an upgrade option, which you can run from your EKS-Ctl component, CLI. When I run an upgrade, it will put in place both the latest version of that YAML file that defined the cluster. So if I want to upgrade Kubernetes, I might go back to the YAML file that defined my cluster, find my Kubernetes version, upgrade that to a newer Kubernetes version, possibly change my templates, and run an upgrade command. When I run the upgrade command, EKS-A will manage a rolling upgrade, taking each of my Kubernetes nodes and their virtual machines one by one and provisioning a new one with the newest version of, with the specified version of Kubernetes in place, with the latest versions of all the other software need be, and with any other changes I've made to this manifest. And once that new instance is up and running, it'll be incorporated into the cluster and the old instance it's replacing removed. This cycle will repeat through all of the control plane worker nodes until you've got a cluster operating at the new versions that you want with zero downtime. The other thing you may want to do ultimately is rescale, and that's accomplished through this mechanism, similarly, where I can simply go and change the value for the sizes of these different classes of deployments, and then simply run the upgrade process, and the system will scale up to the larger or smaller scale as specified. Now, we're going to see some better ways to do this in a few moments, but this takes us to the end of the demo phase where we've actually brought up a cluster and taken a quick look at some of the management capabilities on that. Let me throw it back to Vipin at this point and have him talk us through some of the other exciting features of EKS-Anywhere.
All right. That was a demo from Joe, showcasing the wonderful features that EKS-Anywhere has to offer. I just want to plug one more in, which is diving in a little bit to diving more into the GitOps feature, which both Pippin and Joe mentioned. Specifically, what it allows you to do is, instead of manually managing the YAML files in, sorry, let me pull up the slideshow. Instead of manually managing the files in your local file system, you actually are able to manage all these YAML files and configurations in GitHub, so under version control. And what that allows you to do is have continuous integration, continuous deployment, be able to review your changes via some pull requests. Also gives you a clear historical log of all the changes that took place on your cluster, and also supporting rollbacks, which is really, really powerful and much easier to manage a production environment than just having these YAML files scattered all over the place. And on that note, I will hand it back to you, Vipin.
Cool. Thank you, Max. So I hope the demo was useful for you folks. And like if you have any questions, I'll give you an email address where you can reach out to us. And I do want to call out something. So EKS-Anywhere is open source. You can download it from GitHub, start running it and using it for your production workloads. You should have all of the components that you need for it. That's our goal. Additionally, if you want, let's say, like more curated packages, like there are some curated packages that are right now, like available for customers, but it requires a subscription. So we give you the secure and tested EKS-Anywhere control plane components along with open source tooling that you get with EKS-Anywhere. You also get 24/7 access through our Kubernetes support team as well as the EKS engineering team. Like I mentioned, the curated packages require some kind of like contracts with third parties for like support on an ongoing basis. So if that's something you're interested in, you can purchase an EKS-Anywhere subscription. We also offer well-architected reviews and onboarding assistance to make sure your environment is ready to like support your mission critical workloads. So the EKS-Anywhere support subscription is a per cluster subscription. So you have two options. You can either purchase subscription per cluster for 1 year at $24,000, or like if it's for 3 years subscription, then you get a discount and it's like $18,000 per cluster per year. And of course, like if as a customer, if you have any private pricing agreements or discount agreements with AWS, we can factor those in onto those list prices as well. Next slide, Max. So I want to leave you with some additional information. So we have a pointer to a landing page, the open source documentation that Joe walked through in his demo. That's the link over there. And like I mentioned, the project is open source, so you can go over to GitHub and look for EKS-Anywhere, EKS-Anywhere as a repository. And for information on the subscription pricing, you can look for it on the EKS-Anywhere pricing page. So next slide, Matt. Yeah. So in terms of our key takeaways, we hope that like this session was useful to you. So we've talked about EKS-Anywhere, which is an open source project. You get consistent controls for running Kubernetes on premises and in the cloud. with EKS-Anywhere and Amazon EKS on the cloud. Our goal is to give our customers simplified installation and our Kubernetes operational management tooling. It's fully supported by AWS, and you get all of the security and operational reliability that you get with EKS on the cloud is all available to you now on premises. And we have a rich partner ecosystem. ShapeBlue has been one of our key partners we work with. So and we have other partners as well for observability, for like security, for operating systems. We are working with a bunch of partners, and we have a rich partner ecosystem there. Next slide, Max. So I want to leave you, with an email address where you can reach out to us. It's aws-custfeedback-eksanywhere@amazon.com. Feel free to reach out to us. Our team is available if you need any help or if you're interested to learn more about EKS-Anywhere. With that, I want to say thank you on behalf of Max and I, and Joe as well, who's here for the demo. So thank you, everybody, and hope you have a great rest of the CloudStack Collaboration Conference. We have a couple of minutes, so if you have any questions, we are willing to take them right now.
Very much. Thank you very much, Vipin and Maxwell. I think we had quite a few questions. I don't know if we're going to have time for it, but I think first one was what versions of CloudStack are currently supported, and where do you see this endeavor going?
Yeah, Max, do you want to take that one?
Yeah, I believe we have tested fully support for versions 4.14 to 4.17.
Cool, very, very, very interesting. And where do you see your integration with CloudStack going?
So, like I mentioned, we've built the cluster API provider for CloudStack from scratch. So, it is a great experience for us, and we were successfully able to have the project join the Kubernetes SIG. So right now the project is part of the Kubernetes SIG sub project, and we are going to be working with ShapeBlue and on maintenance of the project. And if there's anybody in the audience or anybody in the community that's interested in working with us on CloudStack, on the cluster API provider specifically, that reach out to us, we'd love to engage with you as well.
Another one, I think we have time for another one. Interesting to see you choose CloudStack as your first on-prem offering after VMware. Why is that?
So it's actually the third on-prem offering. So we had VMware vSphere as a virtualization, first one, second one was bare metal, and third virtualization is CloudStack. And the reason goes back to what I initially said. Many of our customers wanted to use open source software and all aspects of it on premises. With CloudStack, customers get an open source virtualization layer that they're able to run fleets of virtualized machines on premises at scale. And that was the reason we went ahead with CloudStack as one of our provider options.
Thank you very much. And last one, I promise. At what scale has this been tested?
We have tested it on customers running across production workloads. I'm not able to share exact numbers, but we have customers running across the financial services industry, tech industry, gaming, and many other verticals that they've been using it in production. And for financial services specifically, you can think of it as real-time updates that they need. Gaming is as well as very compute intensive, so pretty high scale that we've tested.
Thank you very much. Why would I use EKS-Anywhere to manage my on-prem CloudStack when I could use CAPC directly?
So EKS-Anywhere provides you the abstraction of not just the cluster management, but also the additional tooling that you get. So think of it as a customer, if you're running Kubernetes on premises, yes, you need to manage your Kubernetes cluster. You need to create, update, and delete. But you also need additional tooling, things like a CNI plugin. You need GitOps. You would need an operating system on which to run, because cluster API does not give you the operating system. So there's a bunch of additional tooling that we provide with EKS-Anywhere, as well as make it easy. So by giving you an abstraction on top of cluster API to provide a consistent interface. So you can use the EKS Scuttle CLI that Joe talked about. You can use it if you're running across on-premise and the cloud. That is your consistent CLI that you can use for managing all of your clusters. So you get a lot of value adds on top of just using cluster API with EKS-Anywhere for running Kubernetes on premises. Thank you,
Vipin. That makes a lot of sense. And thank you very much. And yeah, it was really, really great. And this looks very, very interesting. So thanks for joining this conference.
Absolutely. Thank you everyone for the opportunity. It was great to be in front of the CloudStack community and look forward to collaborating with you all. Thanks so much and have a great
Thanks so much.